Okay, so Unit 2 is over the numeric system and its properties. Okay? So, with this unit, we're going to be talking about what's called a set of numbers. Okay? More specifically, when we look at this skill, the set of real numbers. Okay? Any collection of objects, you call it a set. Okay? So the set of real numbers is the collection of real numbers. Okay, we'll get more into that. With this set, we're going to, or with this unit, we are going to be adding, subtracting, multiplying, and dividing real numbers. Okay, we're going to perform operations on real numbers. Okay? After that, we'll work with matrices. Then we're going to move on into the properties of addition and multiplication. And from there, we'll move on to what's called radicals. Okay? Gnarly. Get it? Graham got it. Search for dude. Righteous. Alright. Anyways, besides the point. So, the first skill 2.1, we are ordering and comparing real numbers. Skill 2.1, ordering and comparing real numbers. Alright? Any questions for that? You will. Yes, ma'am.
For the vocab, do we only have to do the words you listed or all of them?
Okay, for the vocab, good. You guys can read pages 63 through 66. The vocab I want you to focus on, or what I want you to have written down, are these up here on the board. We have real numbers, origin, positive and negative numbers, integers, opposites, and absolute value. Okay? There are other vocab terms I do want you to look at, but I don't think they're necessary for you to write down. Okay? Is that clear? Focus on these ones, but still read the other ones. Okay? Also, I want you to look at all 7 examples. So, you guys really need to read the section. Don't skim. Read it. Teach it yourself. See what's going on, so that when we come back, I ask you questions, what are you going to have for me? Answer. Alright? So, what did we read about? Let's go.
Numeric systems and properties.
Well, we haven't read all about the numeric system and its properties. Okay. Okay. Ordering and comparing real numbers. What else did we read about? Grading?
Integers.
Integers. Dakota?
Number lines.
Number lines. Good. Anything else? What was the... Go ahead.
Graphing.
Graphing. It kind of goes with number lines. We'll talk about that. Big picture-wise, what are we working with? What? No, who said it? Real numbers. We are working in the world of real numbers. Okay? So we're going to show that world up on the board. Alright? This is the world of real numbers. Thanks. You getting this camera? Good circle. Real numbers. Go ahead and get this. This is going to be your biggest circle. Okay? I will let you, well, you have another circle. We'll talk about that group. And then there's another circle. We'll talk about that group. Then there's another circle. These circles are getting worse, but more like ovals. And then another circle. Or oval.
How many?
Man, I started off with a really good circle. There's 5. Yep. So, real numbers is a large set of values. Okay? listed off numbers.
4.
4, 17, 92,
1002.
1002, 0, 6, 55.
4.
How about 4.7658921432
Yeah, sure.
Pi. Euler's E. 1/4, 1/5, 3 thousandths, and the number 10. Those are all real numbers. Okay? It's the large, they all belong to this big old world. Okay? Real numbers. There's another type of number. We have another name for it that we're not going to work with quite yet. I'll help you get that the word. This is my friend Bobo. He's a dolphin. He wears an eye patch, and he speaks monkey. What is Bobo?
Fake.
What did you say earlier?
Imaginary.
Imaginary. Okay? There's two large sets. There's real numbers, which we're working with, that you work with in everyday life. And then there's imaginary numbers. Imaginary numbers are used a lot in physics and engineering. Okay? We'll introduce you to those, to imaginary later on in this unit, but we're going to focus on real numbers. Okay? So I said the real numbers is a larger set. It's a larger collection of values. Everything goes. Okay? These are smaller sets that only certain numbers can be in. What's one of those groups you read about? Integers. What are integer numbers? What are integer numbers? Trey?
Negative or positive numbers.
Negative or positive and 0. Okay, so negative 2.4. Is that an integer?
Yes.
No.
No.
Whole numbers.
Negative and positive whole numbers. Complete numbers. Okay? They fall in this group right here. This is our integer group. Integer. Okay? Integer. 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 No. Integer. Those are your negative, 0, and positive whole numbers. So no decimals, no fractions. Okay? There's also a group that's just 0 and positive numbers. So 0 and positive numbers, would they belong to integers or would they be outside of integers?
Inside.
Think about it. Do 0 and positive whole numbers fall into what integers is all about? So it would be on the inside of integers. Does that make sense how it would be on the inside of the integers?
Yes.
Because they already fall inside for integers. They count as integers, but they're their own group too. So 0 and positive numbers are what we call whole numbers. Okay? Well, then there's another group that's just positive whole numbers. No 0, no negative. Where would they fall? On the outside of integers? Or would they fall on the inside of whole?
Inside.
Yeah, because whole numbers are 0 and positive numbers. So that means the natural numbers, fall inside the whole. So natural is kind of your smallest group. Then you add some more. You add 0, you get your whole numbers. Well, then you add negative whole numbers. Then you're up to the integers. So we've done negative whole numbers and positive whole numbers and zeros. What type of numbers are we missing? Decimals and fractions. Okay? Decimals, certain decimals, and fractions, mainly fractions. Because some decimal values can be written as a fraction, correct? We call those rational numbers. Can you write negative 2 as a fraction? How do you write negative 2 as a fraction?
-2/1.
Negative 2 over 1, right? You can write any whole number as a fraction. You just write it over 1. Okay? Any number that can be written as a fraction is what we call a rational number. What if we have a number that can't be written as a fraction? We call that what? If you're not rational, you are irrational. Irrational numbers cannot be written as fractions. Okay? Can you write pi as a fraction? No, because pi never ends. Okay? That's why we call it irrational. It never ends. Okay? So irrational numbers are kind of sitting in this area of the reals. Okay? But all these groups, all these numbers, they belong to what group? The reals. Okay? I just like to say the reals. It just sounds like it's cool. The reals. So when your mom and dad ask you what you learned tonight, you can go, the reals. And then just walk away. Okay? Good. So, there's a way we can represent these real numbers visually. How so? How can I represent these real numbers visually? Writing them down, yes. How can I organize them? On a number line. Have you guys seen number lines before?
Yes.
Yeah. Okay? On a number line. Where are my notes? I lost them. Oh well. Here is my number line. Okay? Go ahead and copy it. Copy my number line. What's one very important part of the number line? Zero. What's that? What do we call zero on a number line?
Origin.
The origin. Okay? The number 0 is so special because it's not negative, it's not positive. It's a different man, it's a different breed. We call it the origin. I can make a video game, that would be like a cool place. You must make it to the origin, or you will die. I'm not later on. Origin. Well, what else? What does the origin do? What's its main purpose? Pitch go.
Separates negative and positive.
Oh! Very nice. It separates the negative numbers. What sign do we use to represent negative? The subtraction symbol. Okay. Boop. Negative. And the positives. So what represents positive? The addition symbol. Okay? So you notice, positive is to the right, negative to the left. Positive to the right, negative to the left. Perfect. Alright? Good, 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 good. So, we call this number line. Another term for this is called a graph. Have you guys heard of the word graph?
Yes.
This is what you call a one-dimensional graph. Why? It's going in one direction. There's only one direction you can go. A coordinate plane, you guys have probably seen worked with like scatter plots and whatnot, line graphs. That's called a two-dimensional graph. Because how many directions can you go? Two. You can go up, down, left, or right. A three-dimensional graph is the world you're living in. You can go up, down, left, right, forward, back. Right? I've got 3 ways of motion. Okay? That's why we live in a three-dimensional world. So when they're making these 3D TVs, they went from just going left, right, up, and down to left, right, up, down, backwards. Up, down, left, right, forwards, and backwards. Well, they don't really go backwards, do they?
Kind of. I don't know.
Sometimes? I've never seen anything in 3D. So, anyways, this is a one-dimensional graph. Alright? So, let's do our first example. I want you to graph the numbers -6, 2.4, negative 1/4, and 5. We're going to graph the numbers negative 6, 2.4, 1, negative 1/4, and 5. How am I going to graph these values? Somebody besides Meldrum. Somebody besides Hall. Asa, how am I going to graph these? Make a number line. Good. So I'm going to make my number line right here. Well, what should I start off with for this number line?
0.
What's another word for 0?
Origin.
Origin. Why do I need the origin for this case? Good. We have both positive and negative numbers. And Sage, what did you say the origin does?
Separates the negative and positive numbers.
Separate the negative and the positive numbers. So I'm going to put my origin in. It's going to go in the middle. Well, with every good graph, with every graph that's done well, it has a scale. Okay? It has a scale where the dashes are a certain value. Well, what can we make our dashes be for this graph?
2, 4, 6, 8.
Okay? Do we need to make it 2, 4, 6, 8? Can we make it smaller?
Yeah.
Can we make it 1? Just go by the integers. Just go by the integers. And the integers are what again?
Whole numbers. Positive and negative whole numbers.
Positive and negative whole numbers and
0.
0. Because it's 0 positive or negative? Neither. Okay? So negative, positive, whole numbers, and 0. So I'm going to do my scale by ones. 1, 2, 3, 4, 5, 6, and 7. We'll go back the other way. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. The negatives make you use up more room because you have to add the negative symbol. Okay? Well, good. Well, what do I do? How do I graph a number? Great, I made a line. Woohoo! What do I do then? I want somebody from you. Michelson, what do I do? What does it mean to graph?
I don't know how to explain it.
Just do your best to explain it.
You take the numbers and put little dots where they are.
Okay, good. You look at the number and you place a dot where that number would fall. Okay? Another word for that dot is called, well, you're plotting a point. Good. We're plotting a point for that number. So negative 6. Starting origin, go to negative 6. Boom. I plotted a point at negative 6. What's my next number I need to plot? Dakota?
2.4.
2.4. Now, where the heck does 2.4 go? I don't see a 2.4.
A little less than a
Little less than a half. Boom, right there. Little less than a half.
Little less than a halfway between 2 and 3.
Little, close to halfway between who?
2 and 3.
Positive 2?
Positive.
Positive 2. Okay.
May I have your attention for announcement?
Oh.
First of all, senior football shirt order forms are in the front office.
So right here we put 2.4.
Football shirt for seniors. Stop by and pick up an order form.
I'm gonna put it right here,
Also,
negative 6.
JV varsity. Oh,
Let's
all
finish
football
this
players.
up.
I'm sorry, 9
Next
through
one.
12 football players. Please report to the cafeteria or the commons area. And as soon as you got your treat, report back to your advisors.
9th grade and 12th grade football players. Of course, the common area during advisor. Woo. Okay. Next one. Graded.
You put it just to the left, just a little to the left of the grid.
And who was that for?
Negative 1/4.
Good. And my last one? 5. All right. Tomorrow, we'll finish this up by